and their examples. So structural isomers and their examples. Examples. Okay. So with this, structural isomers and their examples, right? The way we go about this is that first we need I usually best think of it using an example, but just to get a base of what structural isomer is that when you're giving the same molecular name, but the compound itself looks different. So a perfect example would be like C9H16O. Oops, sorry, wrong up there. C9H16. So the reason why I put that is that this can be written in so many ways, okay? So I hope my math was right. I do believe it might be H18 because it'll be 2n plus 2. Because the oxygen is there, it's going to take it up. So I think we have this. 1, 2, 3, 4, 5, 6, 7, 8. So that's C9. And the hydrogens are all around it. Then we have maybe one oxygen here. But then I could have drawn the exact same picture and oxygen here, and both of them would have such different names of what to call a compound, but this is an example of a structure isomer and a compound, because now this one has, if I count it, 1, 2, 3, 4, 5, 6, 7, 8, 9. We had no name, okay, and then we have 1, 2, 3, 4, 4. So 4 octo, and it did the oxygen is just right there. I want to say oxo instead. I'm trying to figure out how to do this. Maybe instead of this I can do C9H19O, which allows me to add one more. Maybe C10 actually. C10, add one more. Just trying to figure out how to do this. Actually, you know what? Let's stick with what it is. C9H. Because it's just an example. We have an oxygen there, like kind of ketone body. But this one, exactly, if I remember the names I would tell you, but this one have a different name from this, because these two have oxygens at different points. So with that being said, that's what they mean by structural isomers, things that have the same molecular formula, but just different, completely different outlooks. And you can typically only find out that they're structural isomers by, drawing both situations. Well, first writing down what the molecular formula is asking for, and then, trying to get as much of a glimpse as possible in regards to like what it looks like. And then from there, I believe you should just kind of do trial and error to make sure that what yours is what's actually reflected on the answer. So with that being said, let's see here. Structural isomers are compounds that have the same molecular formula but in a different way. Atoms are connected to each other. An example would be like butane and 2-methylpropane. So exactly, see here, if you count the amount of carbons, okay, even though they're structurally the same in regards to what it constitutes with, if you count the amount of carbons, they both have 4. But like this one has 2-methyl, because methyl kind of sticks out, propane, rather than it being just a butane. And it's still the amount of the same hydrogens, and still the amount of the same, I guess, naming rules, in a sense, just we have to really watch out for it. And that is pretty much what we need to know. It's just that for structural isomers, it's how the elements are rearranged. So this is correct. So let's go to question number 8. Jeez, what's going on today? A lot